Hello again on a very wet and rainy day, just as we're about to approach winter. So this is a good idea to do this before the big power cuts come, because you know the government runs the country so well. This is the battery we're going to be using for our power supply, our emergency backup power supply with our small 11-pound inverter. And I haven't been able to use this yet because we had a little balance board on here which went pop, so I've taken that off. And I can't find it at the moment. Where did I put it? I'll put it anywhere. Anyway, but our Dally BMS has arrived. This is a 7-volt 7S 24-volt BMS, and it's got a little balance lead on it. Now we could use the balance lead for the balance board, but unfortunately it's wired the wrong way around. So we're going to have to use the lead that came with it. So we're going to have to wire all this up. So it's black is most negative, and it goes up to the very end, which is the most positive. So we go, where's the negative side? Negative side here. So from here to here to here to here to here, all across each individual cell until we get to the most positive cell here. That's how we wire that in. So for now, I need to cut this back, cut these wires off, desolder these old balance lead, and then I can get to everything to solder the new balance lead on. Exciting times. So what I can do is I can peel this tape back slightly, get to the joint, desolder the joint, solder the new wire in all the way along, because I've put the wires in at the top, which happens to be a good idea. And that way I don't need to uncover all of these cells and create a risk. So the more you can keep these covered, the better, because obviously draw something metal on here between them two cells, you're going to have a small explosion on your hand. So we'll keep them covered up as much as possible. All the balance leads have now been removed, and I've disconnected the negative side of the battery pack. I don't know if to leave that wire there, because I need to turn it all back and I'll just re-tape it all, because I mean it isn't going to go anywhere. Should be fine. So what I need to do is add these balance leads to it. So black is the most negative, so black goes there. Then I just work my way up the connector, going black to the next wire, to the next wire, to the next wire, and then go all along the battery like that to make sure I get to the most positive, which will be on this side, which should be the very end, this wire here. And then on the actual BMS itself, you've got P minus and B minus. P is pack, B is battery. So this lead here, the black lead will go onto that lead there, and then this blue lead will be the one that goes to the connector. So go on this way here. Simple. So I shall do that now. First lead connected, so that's the P minus, pack minus, and the first balance lead. I've just put a bit of tape on this lead as well, so because this is effectively ground now, so if this touches something else, another cell, then again explosions. So take this out of the way on the back here, take that there, and then I can move the battery around without blowing myself up too much. Hopefully. That's the plan anyway. Balance leads all connected, so I've just got to go along with a meter and just check that these voltages go up incrementally. So I start from 0, going up to the 24 volts that this pack will be, and then we can connect our lead here to our output on our connector. And then once we've done that, we can then plug this in and hopefully no smoke emits. And that's it all wired in. So plugging that in, nothing exciting happened. And it's all taped together. Now you may think that tape is excessive, but if you ever see one of these cells get shorted out, you'll agree it's no longer excessive, because there's no danger of things touching stuff now. And then that's your input output, and you can charge through this, charge through that, discharge, and all that jazz. So we should have power on that, and we should be able to pull some load. Should we give that a go? So this is plugged into it now, this lead in here, but it's not turning on, so these lights should turn on up here. And if we measure the connector, we'll find out why. Meter into the plug output, and we're measuring 7.77 volts. That's not 24 volts, is it? So if we go from the negative lead on the battery, which is up there, and we've got 20 volts, and that's measuring from the top of the battery to the positive of this. Remember, the BMS cuts out the negative side, so because there's no output, this BMS must be turned off. Now I think to turn it on, we basically have to charge it. So put 4.2 times 7, which is going to be 29 something, into here. And current limited, of course. and that should turn it on, I believe. There we go, 27 volts from the power supply. We'll whack that into the plug. Here, what could go wrong? Found the problem. Nothing to do with the BMS, actually my soldering. Look here. See this link? Can I focus anymore? There you go. If I push down, you can see it moves. You see that? You might not be able to see that. Anyway, that solder joint has come undone. So I've got to cut around this Captain tape and get into there and resolder this link here. That's annoying. That link has been resoldered. Measuring it from here again, we're getting 24-ish volts. Let's plug in our inverter. There we go. Inverter's on. We have lights. Plug in something USB. We have a light. Woo! Oh no, it's not high load. Do that. Fan comes on. We're AC, so we should have AC out, as we proved in the last video. There you go. Battery works with the BMS, and that will switch off if the battery gets too low as well. So yeah, and let's try a bit of charging. This is our 27 volt DC power supply connected. Currently drawing an amp, and we're getting 22.1 volts. So it's slowly going up. It was 23.9. So it's working. We're charging that as well. So it all seems to be working. Cool. So that's the battery side of our little project done. So we'll leave it there for now. So for now, we'll see you later. And goodbye.